Another important property of Fourier transform is to find the Fourier transform of the differentiation of a signal, continuous time signal. The general rule said that if you have x of t and you differentiate it in time, so what is the Fourier transform of the whole thing? It will be the Fourier transform of the original signal multiplied by j omega, all of it raised to the power n. So let's just take a special case. If n is equal 1, it means we are differentiating the signal only one time with respect to t. So you get x of omega and multiply it only by j omega. An example that if you have this signal and it's equal to one half for the time between negative 2 and 0, and then it's equal negative half between 0 and 2. So when you think about the differentiation, you said, okay, what is the integration of this one? The integration of this one will be a straight line of slope equal like t or something like that. We like slope has a straight line, slant line. And this one has like a negative slope. The triangular pulse it's the same thing. Remember that here the slope is equal half. So you got to draw a straight line of equal half, right? So that's 1, the height is 1, and here the horizontal displacement is 2, so 1 over 2, that's straight line of differentiation equal to 1/2. And the one to the right is the same, but the slope is equal to negative 1/2. So actually now when you look at that, so you can say that the signal y of t that we have it here, these two little squares, the signal is equal to the differentiation of this one, because when you differentiate this straight line, you will get the slope of this one. And just let me just elaborate a little bit more. If you write the equation of this one to the left between 0 and negative 2, what you will get? The equation of this part. You will say that x of t is equal 1/2 t plus 1. And that's from t from 0 up to negative 2. What about the second part? You will find here that x of t, this part is equal, the slope is equal negative 1/2 t, and the y-intercept 1 plus 1, and that's from t equals 0 up to positive 2. So if you find the differentiation of this part between 0 and negative 2 will be half, and the other one to the right will be negative half, and that's what you got. You got the differentiation equal half between negative 2 and 0, and you got the differentiation of the second part is equal negative 1/2 between 0 and plus 2. That's it. So this signal, if you differentiate it, you get this one. So you can write that y of t, the one here in the top, it is the differentiation of x of t. All right. So y of omega will be equal j omega times x of omega. So my job now is just to find first x of omega. Well, x of omega, it's a triangle, and we know for the general triangle pulse of width tau, its Fourier transform is equal to tau over 2 sinc square omega tau over 4 pi. In our case, the tau is equal 4 because it's from negative 2 to plus 2. So you can write x of omega is equal, tau is equal 4 over 2 sinc square 4 omega over 4 pi. All right. So now y of omega is equal j omega times x of omega. I'm going to write x of omega, what I got here, but I simplify it. 4 over 2 is equal to, let's have different colors so I know what I'm going to do. X omega is equal to, and sinc square, and 4 cancel 4, omega over pi. So that will be the Fourier transform of y of omega. That's easy. We didn't integrate at all.